The pesky. Good morning. Good morning. The Zig Lord. Huh? You know if there is any good reference on all the design decisions and trade-offs considered for Zig IO design? Man. That's that, you're asking a lot. I can give you some sources for some of the design decisions. About all of them, I think this stuff happens in the brain of people, so you can get a partial view. I don't think you can realistically get a complete view. If Zig was done committee style, there would be more information. No, not, by the way, I'm not saying that there isn't. I'm gonna give you some, but yeah, all of it is hard. So I'm implementing my compiler right now, and I'm wondering what people thought about it much longer have come to think. So I think New IO doesn't even have a proposal. I think there's APR. So let me put it this way. Hey Josh, how's life? Actually pretty good. I don't remember what I was doing when you were here last, but I've been working on this Radix report, and I made my own abstraction for flexible array members, and it's working pretty well. And now I'm getting to the point where I feel confident in designing more of the API surface and adding a little bit of capabilities to it. So it is great. Okay, no more ray tracing. Yeah, no, I'm done with that. So sorry, let me answer this one though. By the way, you might help me with this one because maybe you have you remember some resources that I don't remember. So let's see. I would never consider async await, and I get supporting DST. DST? I think you might need to unpack DST for me, but I'm quite naive on the potential options and their pros and cons. Oh, deterministic simulation testing. Sorry, I'm there now. You would never consider because you can get a deterministic IO backend, right? Yeah, totally, of course. You would never consider async await. Why would you never consider async await? Sorry to ask you this question. I promise I won't continue answering your points with other questions, but do answer this one because I think it would be a good point to a good way of like aiming the conversation in the right direction. So should I put a countdown? No, I mean there's no point I think in a countdown. In any case, here's the plan. I'm gonna answer this question. Then we need to do a little bit of Zig day maintainer work. It's gonna be very short, so very quick, probably 20 minutes tops. Then I want to add more APIs to my flexible array library for Zig. And then we continue the work of implementing a Radix tree in Zig. So last time, which was yesterday, we did a lot of work. We implemented all the insertion algorithm. The only thing that we're missing is rollbacks in case that at some point you run out of memory and you have done some like partial modification of the tree. So we need basically a way of undoing those changes when in the defer path. And but to do that, we need to basically implement remove, because to undoing those changes is literally removing from the tree the partial insert that we did. So I'm going to implement that next. And then we have search. Although search can be done separately, it's not important right now for the purpose of what we're doing right now. Yeah, so we're gonna do this. And then what else? Well, I mean, this is all probably gonna take the whole stream, not like doing this stuff. So this is probably it. By the way, as a secondary discussion point, how's it going with the parser library, Josh? Did you? Oh, wait. I want to see the replies. I want to see the replies. How much bike shading is happening? I'll clarify. I would never build in async way directly to the compiler. Okay, understood. Well, you wouldn't need. Okay, here's the problem. By the way, did you read this? Okay, sorry, I'm jumping from topic to topic, maybe a little bit too much, but that cannot be reached. Yes, because why is the browser suggesting the localhost version? Okay, so did you see this post? Asynchrony is not concurrency. I'll share a link in chat in case you haven't, or you know, at least for other people. Work, send. So here's the idea. This one, and also, you know what? Maybe I should have led with the other one. This one also, Zig's new Async IO. It's not exactly what you were asking in the beginning. Like, this is not a complete list of the trade-offs considered. But it does recap many of the features and what they do. So let me put it this way. If you haven't seen any of these blog posts, maybe do read them, and then we can continue. And like, my point is that I think we can have a good discussion after this. Start with Zig new Async IO. Start with the second one, and then go to Asynchrony is not concurrency. Okay. Discussions have been pretty tame. Nice. You know what? I have an opinion to share. I see that some people are talking about adding support for subcommands. I strongly disagree. Like, I'm a big user of subcommands, and I myself have wondered in the past how to do subcommands. Like, what is the best way of doing that? Or, well, maybe not best necessarily, but like, what is a good way? And yeah, I think it's a bad idea. They absolutely do not belong there. Yeah, cool. Absolutely not. Not sure if this fits into the minimal scope, but you can get very far by supporting custom types with a decal. In Ghosty, we do something similar to this, but for our CLI personally. But our CLI personally is also the config personally, so that it always matches. And if a type has a decal parse CLI, then we call it. It looks like this. Okay. Value is optional because the stressful will pass a null value versus empty string, so we can detect the two cases separately. Oh, he does null for flags without values. Interesting. We pass off as a pointer rather than returning itself, so that we can detect and change behavior on repeat args, such as foo1, foo2. Might override, might append, up to the type. We have slightly more complicated optional form for more friendly error messages. It reminds me of your passing an IO monad, but as a value, like Zig allocator. So passing that info as value instead of type info. I would recommend, I don't know what type of language you're making, so maybe in the context of your language, monads are a more useful concept. But I would caution against doing that kind of reasoning with what Zig is doing. Also, IO is really not a monad because you don't lift into it. You don't combine IO operations. You don't have a function that unwraps from the monad, performs the operation, rewraps in the monad. So you don't have any of that. You could argue that future is monadic because you lift into a future by using async, and then you're still missing the other one though. So in a wait is for extracting, but you know, I think it's you're really not gaining anything by thinking about that stuff. Like, seriously speaking, you really gain nothing. IO is just a standardized interface for doing IO operations, so that you can have different implementations of it, some of which are provided by the standard library, some of which could be provided, by third parties. And by having a standardized interface, what you gain more than anything else, like the main benefit is that if somebody comes up with, the Zig version of Tokyo or whatever, they can still make any library written in Zig will be able to interoperate with that IO implementation because everybody uses the same IO interface. I would say that is 95% of the point of the IO interface. It just standardizes this aspect. It's just encoding information that the function uses IO. It does that, yes, because yes and no. So if you see IO, if you see a function that accepts an IO parameter, then you know that it's doing IO. It's more nuanced than that because reader and writer, the interfaces, will wrap IO if they need to. So you can create, let me put it this way. The reader interface and the writer interface, you can create those things off of, real IO. Like you can create a file reader and a file writer, a socket reader, socket writer. But you're not only limited to that. You can create a reader and a writer off of, for example, an in-memory slice of bytes. What is the advantage of doing that? Well, you can have one parser, and the parser thinks in terms of byte streams. So it pulls from a stream by reading, pushes to another stream by writing. And then you can reuse the same parser implementation for the in-memory version and also when doing a real IO. Because otherwise, if you dealt with the concrete types directly, you would need two different implementations. So long story short, a function might be doing IO through readers and writers that it accepts or that it manipulates one way or another. So in a sense, looking for IO parameters tells you, it gives you, if a function accepts an IO parameter, then you can be fairly certain that unless it discards the parameter, then it's doing IO down the line somewhere. If instead you don't see it, then it might still throw other parameters, so you need to be careful. The last way of looking at this, which I think is mildly interesting, is that the fact that IO that readers and writers wrap IO and that a parser doesn't have to accept IO is nice because it's in a sense kind of a I don't know if you ever heard of this, like sans IO parsers and stuff. This is just an idea. I don't think this idea is necessarily the best test idea possible ever. I don't know. I don't want to sell you on that. But this idea of sans IO is basically to write parsers that don't directly do IO, that instead operate on memory only. And you can do something like this under the assumption that you first read the entire protocol from a stream into memory, and then the parser operates on memory. Or, as I was saying earlier, you structure a parser to deal with byte streams, and then whether that byte stream comes from memory or not, it doesn't matter to the parser code. So there's this general idea of sans IO, which I think it's kind of neat. And I think that is why it's a good idea to have the reader and writer maintain a reference to IO if they need to do concrete IO. And the ones that don't, like for example, a reader that reads from a slice in memory doesn't need an IO, a handle to IO. So anyway, so yeah. So Josh, what do you think of allowing a type to delegate its own parsing? In favor or against for your specific implementation? This is an interesting point. I'm not entirely sure what the answer should be. I can think of reasonable arguments in favor and also against. I mean the in favor argument is easy. I don't see a motivation yet. Understood. The argument in favor is easy, right? You extra flexibility. It doesn't cost much to support. I mean, but at least it doesn't cost much to support, at least at the surface level. I guess the point against doing this, which is basically, I guess, a less obvious cost of supporting it, would be that then you need to come up with rules about what this function should or should not do, must or must not do. So, for example, like how much of the input stream is allowed to see, how do you decide what it consumes or doesn't consume, etc. The motivation is that it parses one mem copy of the string before you do the parsing yourself, right? I think that the people in favor of this feature will not be thinking that way. I think that the way they think about this mostly is there any motivation for the flow of control to zigzag into user code before main is called? Yeah. I don't know. I would say this. The people in favor of this feature will not be thinking in that way, I suspect. I think that from their perspective, it's mainly, if not entirely, a matter of convenience. You can basically have, you define one type that does all the work of parsing, and so you get the finished product at the end. And you don't have like more, I don't know, like parsing stages, or you don't have to think about any of that. As for this, yeah. But also, I am personally not entirely convinced that that the CLI parser should be something that runs before main. I believe that there was discussion also about having the CLI parser just be in the standard library, and then what you do is that you call it on the init struct, and so the parser can grab the, or you know what, maybe not even that, but you get the idea, right? The point is that you can also do that at the top of main, and it should be fine. So the idea is that you basically always get a list of strings inside of init, and then you do the parsing later manually, and you don't immediately opt into parsing right away, like directly from, let's say, juicy main. Yeah, it's absolutely minimal. Absolutely, this part is totally true. Still, I think this will be the main mindset behind behind support for this idea. Potential downside for a minimal standard CLI parser is that people should order it into when they shouldn't, settling in for good enough. Yeah, but the problem in crypto code is that people settle for good enough also right now, and the current good enough is probably on average way below the good enough of this CLI parser. The full control is still very oopy. With arbitrary handlers. The JSON API makes a lot more sense because it's a tree structure. And putting your code in the middle of a tree traversal is a significantly better flow control pattern than trying to retraverse it better. Yeah. Sorry, retraverse it later. Yeah. That's fair. I think from my perspective, really the answer would lie, like if I were to do this work, the answer would really entirely lie on how simple you can make the interoperability. If the interoperability can be made very simple, I don't immediately see a reason not to do that. But let me give you an example. Like if somebody wants to make a type that consumes, I don't know, n parts from the CLI. No, you know what? You know what? I take this back. Okay, I think I reasoned about this enough to come up with my opinion. So if you allow types to specify their own way of parsing, then it's probably abstract. Usually, well, you can only give namespace functions to container types, right? So struct is going to be one of the main cases. And a struct will contain multiple things inside. So we'll probably want to consume more than one token from the CLI. Maybe I shouldn't say a token. I should say argument. It will want to consume more than one argument. And so here's what happens. That basically, if you do this, if you have this, which I think you want to have, because otherwise it's going to be incredibly restrictive. Like you have your struct type, and then the only thing you can do is parse only one argument, the one that corresponds to where your thing is in the top level struct. So it's too limiting. It makes no sense. So parse CLI or whatever the thing is going to be called needs to be able to consume more than one argument. But then what happens is that people will implement it poorly. And because of that, what will happen is that depending on which order you put the top level arguments, then you will get confusing behavior because some will be consumed more, some will be consumed less, depending on how well implemented is this thing. So yeah, it's probably roughly the same problem at the end of the day. So no, fuck that. I think that the built-in CLI parser should have non-surprising behavior. It should behave in an extremely consistent manner. You should know immediately what you can and cannot do it. At a subconscious level, like you get used to it, and you know that certain errors can happen, or like certain surprising behavior can't happen with the standard CLI parser. And then if somebody wants to make their own thing, which is more nuanced, it totally makes sense. Although in this case, I'm not strictly thinking about subcommands. It is related for sure, but in subcommands, you purposely, potentially want to interpret a given CLI argument in a different way based on the subcommand fair. Here, what I'm worried about is basically people adding by mistake context-aware parsing. That's my worry. Not doing that on purpose, but doing that by mistake, because I think it's more likely than not if this thing is allowed to consume more than one argument. Yeah. I'm convinced. Okay, let's do Zig Day maintainer work, and then we can get into the main stuff. Let's go. So let's git pull. One feature that they didn't articulate in this issue discussion yet is that the not allowed compile errors are an obvious launching point for competitor libraries to extend the behavior. and be backward compatible with the minimal one. Oh, that is a great point. There is a great perspective. Yeah. The idea is that you have like a good launching point. Right. That's nice. Okay, so here's what we want to do. Content / USA / Los Angeles. We need to add, is it Tristan? I don't remember Tristan's username on GitHub. No problem. Thank you. I'm looking forward to see where this goes. Tristan Pemble, lowercase. Okay. Is New York organizer made any police statement yet? I believe not. Let me double check my email. Nope. Haven't heard about this. Did you see any announcement in the Record Center chat groups? So this was scheduled for September, by the way. So end of September. So there's a lot of time. Okay. Okay, so here's what I'm going to do for now. Settings, rules. GitHub is super annoying. So here's the... I'll explain the problem for people who haven't seen how Zig IO works. So here's what I want. I want Zig IO to be a repository where I set code owners. So I say which accounts are owners of which content. And the idea is that they're not allowed to touch the website in general, but they can modify their own stuff. They can modify their own events. They can modify their own description of their own event. So, so the idea is that organizers can independently change their own event, but they can't change other people's event. And this is done also because, not because I want to rule with an iron fist and put everybody through a set of like restrictions for no reason other than my own pleasure, but because this system sends out emails when you do certain things. So a event organizer should not be allowed to make changes to the website that trigger automatic emails for events organized by other people. That would be pretty bad design. So I originally thought that I could get GitHub to do this work for me because there's this system where you can say, well, I have code owners. GitHub is aware of code owners. Code owners is a file that you can use to do logic on GitHub. And so I have this rule for main where it says, you cannot push directly to the repo. You need to send a PR. And the PR needs a review from code owners. So that way, if somebody sends a PR that modifies other people's stuff, well, they get pinged about it. And you know what? Maybe it's a good change, so they can merge it if they want. But that PR cannot be merged in autonomy. But instead, if you only modify files that you are the code owner of, then that should be allowed. You should be able to merge your own PR. Turns out that this system just doesn't work. It's completely broken in the sense that it's not designed to do what I was hoping it would be able to do. So I can set this and this, but what ends up happening is that whenever somebody sends a PR, then, for example, here, oh, you know what? I'm dumb. It's not Tristan Pemble. It's Jeff Anderson. Oh my god, I need to change this. Yeah, I'm dumb. In any case, I was hoping that the bot would be able to do this, but the problem is that the bot. No, here's the problem. You cannot. Well, I don't know if you can approve. Maybe you can, because approving is different than reviewing. So I can tell you for sure that you cannot review your own PR. So if you are a solo code owner, you can't merge anything. Where am I going? If you're a solo code owner, it's impossible for you to merge stuff because there will not be anybody else who can do a review for you. And so you're stuck. And this all sucks. So what did I end up doing? I made a bot for this. I made code owners auto merge, and code owners auto merge is basically a bot that looks at PRs, looks at code owners, matches every file that was changed with a code owners match. And if you're the only one that, like, if all files are owned by you, then the bot will merge the PR automatically. Now, watch GitHub fight me also with this, because what happened is that, for example, here, Andrew, who is the code owner of Everything Portland, made a PR, but the code owner's stuff didn't work. Why? Because it kind of, like, the algorithm worked. So it says, okay, the submitter is Andrew. I'm going to match Portland 0 against the rule content USA San Francisco. Nope. Yes, this is a match success. Matching user Andrew with Andrew. All files changed matched equals true. And so it's time to merge. But turns out that merge commits are not allowed on this repository. Oh, fuck. This is what caused it to fail. Merge commits. Oh, because I require linear history and we're using merge strategy. Holy shit. Wait a second. We are dangerously close to making this work then. Do I want merge commits? You know what? I don't want merge commits. The bot needs to hit the squash button. Yeah, I think so. I think so. Holy shit, we're so close. Okay, let me fix my mistake here. So it's not Tristan Pemble. What am I doing? Tristan Pemble is actually one of the co-organizers of the Portland one, I believe. He should be up there. I'm gonna ask Andrew if that's okay. Be effective. Force pushing my embarrassing mistakes, as one does. Okay. So here's what we do. Yeah, you know what? I'll just add Tristan Pemble. Maybe we can just add him. Pending review. I'm curious why. So it is in auto merge. One pending check test. The fuck is this? Oh, here's another problem with GitHub. I have this phantom test thing. I think it's supposed to be one of these guys, but I renamed it a little bit, and so it doesn't match anymore. And now there's this phantom check that doesn't exist. Okay, let's fix that also. Also, wait, this one succeeded? Oh. Submitter Tristan Pemble. Right. So okay. So this. Oh, right. The job succeeded, but it succeeded in a don't merge um, end result. Okay. So let's fix the required status check stuff, and then we can fix the remaining thing. Rule sets main. What is this test thing? Status checks test. GitHub actions. I don't know. Remove. Add test any source. Suggestions in release test. Yes, this one. Please. I think that by renaming it, I broke this. Because previously it was called just test. Okay. So we fixed this. Andrew was requested to review. Oh, it requires a review from all of them. I think that's fine though, because it's a nice way of getting notified that somebody's touching your stuff. So for now, I'm gonna leave it at that. And then I think now it's time to add Tristan Pemble as the owner of Zig Portland. And I think we can watch the bot auto merge. No, and also in here, we need to say that code owners auto merge with, I forget how the option is called. I think it's, no, I don't remember. I made it and I don't remember. Merge method squash. I don't know. Let's see. Now the question is, will the new CI, will the new YAML file be taken from the main branch or will it not? So I guess the question is, if we rerun this, what happens? Sure, rerun everything. So this might not work, but I think that this might not work because it was created. It's like it's an old PR. I guess we can click here and see the auto. Um. Did I forget to push or something? This does not make any sense. It should see Tristan. So he's here. I understand not seeing the changed YAML file. And it does not see the changed YAML file. But it does not see Tristan, which is weird because it should grab the GitHub like the code owners file from the latest commit on the default branch. This is surprising to me. Let me try to rerun this again out of I don't know, curiosity. And then what I can do is sync the PR and see what happens if we sync it. But I was expecting a failure though. I was expecting this to correctly match everything, but then fail to do the merge. This is so weird. Let's try syncing the PR and see what happens. This workflow away release approval. Why? Pull request successfully merged and closed. No, Mason! God damn it, Mason did it. Oh no. You know what? I was probably spamming them via email. Sorry. Oh, we couldn't get our test working. That is sad. Man, yeah, I got trolled live. God damn it. One pending review. As a code owner, what does this PR change? So this PR cannot be, it's not a candidate. It changes Los Angeles. And I'm, oh right, I'm the code owner of Los Angeles because because I'm the code owner of everything except what other people are code owners of. Okay, well, I can try to sync this one then, right? Let's try. So what is this one? Number 14. Submitter is me? Submitter is me? I mean, yes. I actually did the force pushing. That's fair. Not even this one can be a test, unfortunately. So let's merge it manually and then. Oh, it's not being merged because of the missing review. Okay, unfortunately, I cannot do any more testing. So I'm gonna need to chat with people and coordinate with them to do more testing. So I guess we won't know if the bot actually works or not yet. But we can take a look at what Jeff added. And it's all well and good. It's just that the photos need some resizing. I believe that the problem here is that the photos need, what is it? With auto. Is this enough? It's not enough. It's with, maybe more than with, it's max with 100% so that they don't overflow the parent. Yeah, that sounds good. Okay. So we're done with this. I'm gonna just quickly see that everything looks fine once it deploys. Actually, it should be already there. Let's see. Yeah. Awesome. So we did it. Okay. Now we can go back into our compile metaprogramming, which at the end of the day, some would say that's all what life is all about. So let's indulge. Okay, this abstraction is awesome. I'm loving it. It works really well. Let's make it better. I added yesterday comp time for generating length structs, and that has given us so much type safety. It was insane. And so I had to make lengths and some lengths. And you know what I realized? That actually having more of these guys never hurts. So here's the idea. Up until now, this design forced you to put a void flexible array at the end. So let me recap. Okay, recap for people that were not here. What are we doing? Here's what we're doing. C has the concept of a flexible array member. The way it works is that, you know what? It's time. It's time for, I'll whip it out. My drawing tablet, I mean. It's time. Writing code in C? No. There we go. So here's the core point of the problem. Let's say that you have a struct that is connected to a variable length buffer. How do you do it? The standard way of doing it is this. This is your struct. And your struct has some fields. And then one of the fields is a slice. And the slice of type T, I don't know, like a slice of bytes, for example, points to another location in memory. Holy shit, this came out big. But it puts an allocation in memory where you have the actual bytes. That works. There's nothing wrong with this. But there's another approach where instead you make one allocation that contains the struct at the top, sometimes called a header, and then it contains a tail with all the variable length data. What do you gain by this? You don't have a pointer because you don't need a pointer. You know what the data is right after the struct ends, with maybe some padding. So you maybe need to do math. But you don't need to store 8 bytes for a pointer. You divide it by 2 the amount of allocations that you need to do, so you reduce fragmentation of your memory. When navigating this stuff, like when reading some of the head and then some of the tail, you go through one fewer pointer dereferencing, and yeah, it just looks good. And if these two guys are related, and then they live in very far away parts of the memory, let's say that this is the entire RAM stick, and this guy lives here, and this guy lives here, that's bad that they keep living so far apart. So with this stuff, you keep everything close. What needs to be close lives close. So this is a technique in C that has existed for a long time, and it's called, or rather, sorry, this technique probably predates C. Actually, definitely predates C. But C allows you to express it using flexible array members. And I say plural, but in reality, you can only have one. So you have a struct, and then at the end of the struct, you declare a field that is the struct, which is the flexible array member. But the point is that this is not a real field. This is just syntax sugar that C gives you to refer to basically obtain a pointer to the end of the struct. Yeah, light mode on Wikipedia. I know. How do I change this? Where's dark mode? Oh shit, you're right. Oh my god. Yeah, thank you. Why are they not doing it using system preferences? I hate this. Okay, so yeah, so C has always done it like this. Now, the problem is this. C, as usual, gives you something, and then it doesn't give you enough, in my opinion. Because you have this bad boy, but then look what people want to do. People want to do stuff like this. So this is a Radix 3 implementation. A Radix 3 is this type of data structure. A lot of pages have our code dark color foreground text. Oh, that's sad. So a Radix 3 works this way. It's basically, you can think of it as a key value store. So like a hash map, but except instead of hashing, what it does is that it's a tree. So it builds a tree of the keys that you put in. So let's say you do cat and I don't know, cats and coat. So you want to put these three words in a Radix tree. It works this way. You have let's say the root node, which is going to be CAT. Actually, what the fuck am I saying? This is definitely not the case. I come up with a example that is maybe a little bit too complex. It's going to be C, and then there's a node where it's either, I'm going to do a square node. It's either going to be A or O, and then this goes into T, and then it can go into well, let's say I'm gonna say X for like no, how do I do this? And then this can be a success because this is the key. Cat is a key, or then from T you can go to S, and S is a terminal node. It's a key. Then O instead goes to AT, and AT is a success. Okay, makes sense. So this is the data structure. What's important is that you have two types of nodes. You have nodes where all the letters need to match. When you're trying to match a key, you're matching all of them one after the other. And then you have, actually, using the same symbolism that I use up until now, I guess this would be it. And then you have instead nodes where you only want to match one letter. Like here, you don't want to match A and O. You want to match only one of the two because you're choosing where to go. And so then you see O and then AT, but AT both need to match. And so it's kind of like this. Okay, Radix 3 has two types of nodes. I call them merge nodes and split nodes. This would be a merge node, and this would be a split node. So look what happens though. The in-memory representations of these bad boys in this library is like this. Header is the struct that I mentioned. So it's a struct that goes at the top of the allocation. And then you have, this is a split node. So this is a node where you have X or Y or Z. One of the three letters has to match. And then depending on which one you pick, you remember there were arrows, right, that went out of these guys. So for A and O, A goes to T, O goes to AT. So each one of these guys has a pointer to another node. And then at the end, there's the data pointer in case that the node is also a key. So when a node is a key, then which I represented like this, then if it's a key, it has internally a pointer to the value. And here's the thing. All of these things are meant to be, they're all, in a sense, flexible. They all grow and shrink depending on the needs. For example, I can tell you one thing. This part is obvious, right? Depending on what strings you put in the Radix tree, then in a given node, you will have a variable number of bytes to match, and consequently a variable number of pointers to follow. And these are the same length. And then you have the data pointer. You also want the data pointer to be optional because in a Radix tree, the vast majority of nodes will not be a key. It will be an intermediate node that doesn't hold any value because it's only going to be mostly terminal nodes that are the ones that contain a value. So what is my point? My point is that if you use C, then this is going to be one flexible array member. We can actually see this in the source code. If you look at rax.h, the definition of a node, oh, by the way, he has also this similar way of representing it, pretty good. Look at the Rax node definition. It's the delightful bit field. This is basically the struct header. And then you have the data. But guess what? Data does not have any form of type safety. You have to do pointer math, and you better do it right. And you also better use, apparently when I was looking at the code, there's a bunch of mem copies where even pointers don't get assigned, but they get mem copied. Like the pointer value gets mem copied around because apparently it's UB not to use mem copy. I don't know. You enter C2T, but actually a single bit. Yeah. That's good design, right? You know, when people say orthogonal design, that's like parallel. This is not orthogonal design. It's parallel design, but also it's parallel, but also like the two, like if you're thinking train tracks, it's like one is bigger, the other one is smaller and crooked and turn 90 degrees to the side. So it's like you can't have a train even go on it. It's delightful. In any case, so this is what people use it for. So as an example, I was going through some of the algorithms and implementing them, and you will see that there is a bunch of bit fiddling going on. Let's find the best example. Let me see if I can find a good example. I know there is one. There we go. So this is, what's this function? Rax add child. And basically this is doing all the math to make sure that everything has enough space and goes into the right place. And to be clear, it's not like this math is completely avoidable because, well, you have to do some of this math, period, somewhere, somehow. But here you can see that this is done specifically for this library. And it's not something that flexible array members give you. The flexible array member feature from C is literally just a convenient way of getting a pointer at the end of the struct plus alignment. Actually, no, you don't even get alignment because you usually make it a pointer to bytes. So it's just a convenient, mildly convenient way of getting a pointer to the end of the struct. It doesn't do anything else for you. Okay, now enter flexible array. Library that I'm making is called Zig Flex. So I'm still iterating on this design, and this is what I'm going to improve now. So here's the idea of flexible array. Flexible array allows you basically to get a type safe handle, a type safe slice to whatever stuff you want to, whatever you want to stuff into the tail of a struct. So here, this is a Rax node. This is an example of the same struct that the C library that I just showed has. But in my case, here you can see that I have bytes. These are the letters and pointers. And I don't just have one flexible array for everything. This is type safe. The way it works is that this guy keeps track of its own length and has a U29 that is put in a packed struct. This one does not keep track of its own length because these two have always the same length. So I know I don't need to track this information because I know that this will always match. So where am I going with this? Where am I going with this? Then what I'm doing basically is what I want to do now is improve this API based on the usage patterns that I've done, I guess, as I was implementing Rax. So I want to make this a little bit better. And one thing that I did in the last set of changes that I made, which I think it's kind of neat, is this. Let me see. Here, when I do flex create of these guys, look what happens if for value I set at 20. Unused function parameter, okay, that's a problem. And then it says type U1 cannot represent integer value 20. So basically, I have type information about the fact, we can see this here. I changed the design slightly because I'm making some changes from the C version, small ones. But here, what I'm saying is that value, I know it's either there or not. So that's why it has length U1. And so you can't give it a bigger number. This one is maybe a little bit gimmicky, but bytes has a similar problem. Bytes has maximum length of U30. And you want to do this because right now it's not packed. But I want to be able to do this. I want to be able to make this work in a packed struct. The reason why packed is turned off is because there's a bug in Zig where field parent pointer does wrong math when the struct is packed, unfortunately. So this is temporarily not packed, but it's gonna flip back to packed as soon as the bug is not there anymore. Okay. So with this in mind, what do we want to do? We want to improve the API for Flex. How do we improve that API? Well, here's one thing that I want to improve. Value is not really an array. It's a single. This is the value that, by the way, this is another thing that we're going to improve. This is the value pointer that in this implementation is at the very end. But I moved it to the left because right now this API doesn't have the ability to have fields placed after a void field. Because here's the point: to get a slice to this guy, or let's say to this guy, we need to basically do math and say from the starting pointer where this struct is located, go size of this struct to surpass the struct contents. Then there's a value field which might be there or not. So I need to look at the field that contains length information, and based on that, decide if I want to move one or past, move size of this type past or not. And then bytes, I need to see the length, decide how many bytes to go forward, etc. The void doesn't keep track of that. And so right now, what happens is that the API doesn't allow you to provide this information. And so I put it always at the end, because putting something after would require the API to get that slice to ask you to know how big this thing is, because we don't track it directly. We expect the programmer to track that. And I don't have this implemented. So I want to implement that as well. But first, I want to do this. I want to add support for Booleans, where the idea is that it's a flexible array. It's U1, basically. You can either be there or not. But if it's a type Boolean, then you can do get instead of slice. Right now, I haven't shown this, I guess, maybe I should. Right now, the way it works is that flexible array, it's a struct that only contains length, which can be either a real type or void in the case when the field does not track its own length. So it becomes a type of size 0. And then you call slice to get a slice. And slice is what does the pointer math for you. So I want to add support for Booleans. And the idea is this. When you do a Boolean, you do this. Pub function get f pointer star this. And we return the return type. Why are we using return type and not t? Let's see. Right, in our case, we don't care. What we return is a pointer to t, no matter what. And then we say this. If length type, if length options.length type is different than bool, then we compile error. And we say get can only be used with flexible arrays with let's change this. Is only available for flexible arrays of length type bool. There we go. So the idea is that you can't do get on something that isn't set to be bool. And then we can literally do this. We can literally just do return f.slice 0. This should be optional now I think about it. And it should be like this. Oh, what am I doing? Like this. If f.len return if.len f/slice 0 else null. There we go. It's literally just this. Very, very minimalistic. We do this maybe? Would this help? Maybe it helps a little bit. Okay. Oh, you know what would help? This would help. Oh, this would help a lot. Yeah, check this out. Get is only available for flexible arrays of length type bool. Perfect. So now we have support for this because I do use slice on the U1 field, and we shouldn't do that. So here for slice, we also do this. That if type length is bool, use get for flexible use get on flexible arrays of length type bool. Perfect. Yeah, this is so good. This is so good. And now we need to also have the metaprogramming support the bool case, which it currently does not. So it requires some work on our part. So let's go do this. Also, let's change this. Type to be used to store length information for the flexible array. Normally, you will want to provide an integer type. But void and bool are also allowed. Bool will allow you to use .get instead of .slice. On this field. Void will make the flexible array not store length information, which you will have to track externally, e.g. by deriving it from other state in the struct, and occasionally provide to Flex APIs. When a flexible array has a void length type, the slice function will return I wish I could use text reflowing, but I can't with triple backslashes, unfortunately. When present, length information will be stored in a packstruct. So flexible array can be used with external. When length field is not void, you can access length information via field.length. Perfect. Okay, let's do this. The length type is flexible array child t. You know what? Maybe for simplicity we can do this also. Const length type equals opts.length type. Yeah, there we go. Let's start using this because this is going to simplify things a lot, I think. Okay, so let's see. From time, p has to be a struct. Len info, yeah, length type. If length type is void, then We check that it has to be the last one. This is still currently correct. This is another thing that I want to change, but that's not what I'm changing right now, so I'm gonna leave it there. I did take it out of the description, but I'm one refactoring at the time of the code. So then we say, okay, if it's not an int, then we complain. So first, then we need basically something else in the middle. So we need here else if length type is bool. Then we do nothing actually. We don't need to check on anything. Should we switch on it? We can't switch because we also need the... no, we can't switch on it. Switch length type. Void this. Bool, do nothing. I mean, which is the same as we were doing with the if. It's just that doing nothing in an if seems so fucking weird, while doing nothing in a switch is more normal, I guess. Else, in the else branch, we do this. No? There we go. If len info is different than int, there you go. Oh, this is so much nicer. So this is the comp time validation. Very simple. Then init. I don't even remember if we use init, but I guess this is fine. So get, that makes sense. Returns a pointer to the flexible value only available when length type is bool. Turns a slice to the flexible array. Not available to the flexible array. If the flexible array has length type set to void, the return value will be t. Otherwise, it will be a slice. Not available when length type is bool. Use get instead. Hello, Yushman. Okay. This seems good. This seems good. So now we need to deal with it in the rest of the meta programming, because now we need to worry about Boolean fields. And the fact that now we have length type in here, this is going to make some stuff less cringe, I think, I hope. Length type equals bool. So type of name, blah, 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 parent bytes, offset, flexible array, type info, field type struct, and has decal is flexible array. So yes. Offset is a line of field type child. Perfect. Value len is this. If name, blah, blah, blah. If the return type is this, return this. Otherwise, this other one. Oh, okay. I think it needs to be like this. We need curlies, I think, around this stuff. So we void bool else. And the else case is implicitly numbers. Okay, so void, I think we can do unreachable. Because when return type t, let's see. Let's see if Zig will complain about this. What do we do if it's bool? That's also unreachable now I think about it. Void and bool are both non. We don't do that. So because bool, you can't use slice. Void, it's the case handle up of here. And then in the else case here, it's basically, it's this. Items and then no if. And to be honest, we don't need to do it like this. Because we can only grab it in here. Okay, I messed something extra thing. Okay. Type of value len. This is field.length type. If field.length type is different than void, there you go. Okay. So we have fixed, I hope, the metaprogramming in here. We'll see if Zig agrees or not. Now we need to do some stuff also with everything else. So lengths, let's see. T is that if the original T is void, usize also original T. That is perfect. This is all perfect, I think, as is. Then then we don't even need to do this. We can do instead of len type. This is field dot type dot length type. Oh, did I do dot type up here? Yeah, no. Dot type. Dot type. Okay. Then some lengths is similar. I said this is field dot type dot length type. Otherwise, the original T. Okay. Then create. Let's go here. Okay, so we have create, destroy, and resize. Oh man, these are the three big boys that we need to fix. Okay. So create this is actually kind of worrying. What the heck? Give me a sec. Some lengths. So I made this, fix this with optionals, I guess. Yeah, okay. Create, I think, still has some outdated code. So we look at every field, and then we look at lengths. And lengths cannot be missing a field because we force it to always have them. So this is an unnecessary check. So we look in there for the field, and then that's how much we move forward. The only problem is that it might be Boolean. So this is a switch where we look at field.type.length type, and we say, okay, is it void? Oh, no, wait, it cannot be that, but it can be Boolean. So bool void unreachable. Bool means that we do int from bool of this. Else means just this directly. Okay, let's see again if this works. Fill is use size. Here we do int from bool. This is unreachable. Else, just the value. Okay, so this should be fine. Then destroy. I think, you know what? I'm going to copy this bad boy because I think we're going to need it more. Destroy requires you to pass in the void len as an optional value. Oh man, this is another thing that we're going to improve on. I'm actually really looking forward to that. Now line forward. And look at this. So metafield info line type different than void. We do this, otherwise we do that. Yeah. Let's improve on this. And it seems that we are not even having any return value. So this is just a normal switch. So this was the void case. And then this was the int case. And now we need to deal with the bool case. Okay, so this was the old code. So we still don't know what to do there. Basically, all we want is a intlen. You know, I almost want to have a getter for that, like something like intlen. We make an intlen function that does the work for us. Hey, Blurrycat, what's Flex? It's my implementation of flexible array members from C, but in Zig with more try safety. And a much more comp time, but hopefully not too much. Yeah, you can find it on Wikipedia. Or you know what else you can do? I think 15 to 20 minutes ago, I went through the whole explanation of what I'm doing. So if you scroll the VOD, I also go through flexible RA members and I explain everything. I even drew stuff in here. So yeah, I know it's a work of art. Um, so if you see me with the drawing stuff open as you scroll through, you know that that's the point you want to stop on. You stream on YouTube too, right? Yes, I do. I mean, you can access VODs on Twitch as the stream is going as well, but I agree that YouTube is definitely YouTube makes it easier, and yeah, you can go there if you want. Yeah, you know what? We definitely want this, man. Oh, but wait though, because this is on something else. Yeah, you know what? It's a helper function basically. We're gonna put it at the bottom. Int len. Bool and from bool. Let's see if we can make int len work and it's not too bad. So this is fine. Here I'm doing this. So I could just do this. Okay. Okay, then new length is some length. Defer, what are we doing? Field name length from linfo. What's linfo? Type info of some length. And then for each one of these fields, grab the corresponding field. As long as it's different than void, and then we assign it to the original value. That works. Nothing has to change. Deltas, blah, 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 blah. Old size, size of, child. Here we go. Field len. It's this guy with a cast to use size. So this needs to be int len. And here we have, we have the else in the void case. I kind of want to turn this into a switch. Let's turn this into a switch. This is the else case. This is the void case. Switch length type. If it's void, we do this. Yeah. If it's not void, so it could be an integer or it could be a boolean. Call int len to turn the boolean into a number if necessary. Then we do the math. If at field, so if the field is present, we do this. And we set it to new field len. Oh, what is new field len? The value from here. Yeah, this is perfect. So this new field len might need a, this needs to be int len as well. Yep. Okay, so this all seems in order. In theory, we did it. Probably have horrible programming errors all over the place that we're gonna need to fix, but yeah, there we go. Reach unreachable code 198. This is not really true. This is Zig just being a bitch about this. Let's see. We're switching length type. Or maybe Zig is not being a bitch. Let me think what this is supposed to do. So create. We're trying to do the math. We have some lengths in here. Actually, this is completely wrong. Wait a second. Here we're just doing the math based on this. Yeah, actually, this is it. This is it. Zig is not being a bitch. That's me being a bitch. Holy shit, that was it? That was the only error that I made? Maybe. Let's see if it still works as we adopted the new API now in Rax. So what am I doing? Where am I going with this new API? Here, check this out. Check this out. Value was it's a thing, it's an optional. It's an optional T. It's not really something that can be, that we have many of. So we do bool. And so now slice is not available to us anymore. Get should be available to us, and the math should not break. Boom. Except that type bool found comp time int. Good point. 145. By default, value is not present. There we go. Expected type usize found bool. Oh, now we have metaprogramming errors. Yeah, so root 108. Where are we? Oh, in slice. No, slice is impossible, man. It's different than void. Right, here we're saying length type is different than void. Yes. Let's do also and field.type.length type is different than bool. Will it make you happy now? It seems that it will. 211. What's the problem here? No, I won't. Expected integer or vector found bool. God damn it! How did you find bool? Oh, because we did this. Right. In create, I think I fixed some of it, and then I forgot to look at the second part, kinda. So let's change this to field dot type dot length type different than void. Int cast. Oh, right. This is old code. Right. This was completely wrong, and now it's actually correct. Okay, cool. Cool. Incompatible types, bool and comp time int. I believe this is in this is here in our racks 75 is key. There you go. If value.len. Accept type optional bool found comp time int 187. True. Accept type bool found u1 42. Huh. Nice. Incompatible types bool and comp time int 131. This can be also parser not and dot is key. Yeah, nice. Use get on flexible arrays or length type bool. Thank you. Where is this in root 186? 196. 196. Yeah. And I did it again in other ones. Accept the pointer type to usize found optional type to usize. Right. How do we do the get API? So does it return optional every single time? And maybe we do question mark if we want to assert, I guess. Alternatively, what else could we do about it? We could make it return the type, but then it panics if it's not present. No, I think making it return always an optional, and then we do question mark on it should be fine. What is std auto? Oh, well, let's do string hashmap. What are we doing in here? Hashmap init get or put. Get return is an optional, and then there's get pointer. I mean, we're not basically being a one-to-one to with that API. I guess we could call it get pointer. Get PTR, okay. Use get on flexible arrays of length type bool. Yeah. And then 138. Okay, then we have this compile error. Why am I not getting the reference trace, man? 194. Oh, here. Wait, what? Oh, 64. Wait, what? What is happening? Oh no, it's 64 in here. Yeah, so fine. Oh, right. I made it a compile error. Oh no, so I wanted to make this a function of slice, but then I made a compile error. So slice impl, which is now gonna be pub, and then pub function slice f colon pointer this turn type, and then in here we call we do this, and then we call return slice impl f dot slice impl. There we go. At this, and then here this calls slice impl. Expected optional pointer use size. Oh, right. 10%. Compile error. Use get on flexible array or length type bool. Okay, so we're back to fixing other problems. Line 249. So get ptr dot question mark equals value dot get ptr dot star equals get ptr dot star. Cannot reference non-pointer type. All right. Use get on flexible arrays 263. No, it's the same thing basically. Okay. Suffix value get ptr. Use get on flexible arrays of length type bool. Which unreachable code. Oh shit. Flex 102. What is happening? Slice implementation. It is unreachable, man. None of this is a runtime condition. What is going on, man? Um, How? Oh, you know what? I think I got it wrong. Void is definitely possible. No, void is not possible. Void is the case up here. Guess we knew this. And length type void. Function with non-void return type u8 implicitly returns void. Where? 82. Oh. Oh. Whoops. And somehow we're reaching into that. How do we reach into that? I guess the problem is that technically it can be something else. It can. I guess the problem is, let's split this into two. I bet you that the problem is bool, not void. Void is correctly accounted for, but bool is not. Yeah, it's the bool line that triggers. Bool is not accounted for because we moved the bool check up here away from it. So you know what I'm doing. I'm actually dumb. Bool is not just reachable. Bool is actually necessary. God fucking damn it. I'm a dumb. That's entirely on me. I want to use this function with bool. There you go. And no, we do want to do this also in the case of bool. Oh my god, we were fucking up the math so much. Okay. I'm oof. Yeah. Type system saved me from myself. Okay. We did it. We refactored it. It all keeps passing all the tests. We now have a much more ergonomic API where we are able to say that this field here is Boolean. It's either present or missing. And we use get pointer. We don't use slice on it, which is good. Helps make the code more clear. And maybe instead of flexible array, I should call it like a flexible member. And maybe we could say kind can either be a single element or an array instead of saying like bool, basically, right? And we could actually return different types. We could say that if, oh, you know what, this would be yet another improvement. We could actually, instead of returning the same type every single time, we could say, well, if it is if it's a array, then it has slice. If it's something else, it's not just that, you know, you can compile error by trying to use the API, but we literally return different struct definitions, one that has get and one that has slice, and you don't get both of them in the same type. So that's another improvement that we could make. But I think that for now, I'm happy with this one step that we made. I want to do more work, but I think one at a time is not a bad idea. So I'm gonna stop here with that, and instead I'm gonna continue with the Radix code. So for now, we did improve the API for Flex a little bit. So let's continue with the tests. So yesterday, after making everything work, I used one test from the original code to test one particular code path, but this is only one of the provided tests, or rather, they're not exactly tests. They are cases that are basically used to explain the different meaningful combinations of things that can happen. And I think we did this one, right? We need 3 already contains this, and we add this word. And so we see that then we basically need to split this and blah, blah, blah. And then there's the other one. This is another case where we do something else. So we need to test this out. So we need to basically, I want to add tests also for all these other ones and see what happens. I'm going to take a quick break. And when I come back, I'm going to do this. So BRB. I'm back. Okay, so let's try a second test case. New test case. Success. This one succeeded too. That one failed. Bus error. Uh-oh. So we got a failing test. So there's a corner of our algorithm that isn't working as expected. Did we fail successfully? No. I would say we successfully failed. Yeah, I did it. Okay. Well, this address, huh? We're trying to write the parent link, and we got this address. Well, on the bright side, it's not null. I don't know, actually. Maybe it would be better if this... Oh, sorry. It's not undefined. So... But at the same time, I think it would be better if this was undefined, actually. Anyway. So... let's see, what are we doing about this? 9389. Wait, 595. Okay, 385. So here, where are we? We're at the end of the while loop. Oh, we exited. So we're finalizing stuff, and this pooped itself. Okay. Let's see when it happened. So I think we are here. I think this is our test. Starts here with this add, then this second add that doesn't do anything, just walks. Then we add this word ago once, and then we try to do it again and we fail. But here's what I can tell you. That the second time, we know we should not be writing anything. We know we should just be matching. So we're failing the match. Adding ago. Oh, you know what? No, never mind. It's the first... no, it's the first time that we added that we failed. So never mind. No, this is correct. We should be adding stuff and we should be failing. So, and it's correct that we only... So there's only this node in the tree for now. And we walk inside of it the first letter and we compare it the first letter and it succeeds. And then there is a failure immediately. And so now it's time to basically do an algorithm to add these things. And this is where things go south. That said, it seems that we do a lot of progress and then we fail. We fell here at the end. Also, this is interesting because there's not a ton of adjustment required. So I wonder what's up with that. I guess we need to reason we need to reason this through and maybe add some more printing. We could try debugging actually. I think it's not bad to do debugging. Can we run this specific test? Is this only the last one? No, these are all tests. Oh, well, that sucks. But I guess we can put a breakpoint manually in here. Check this out. At breakpoint, we rebuild, we fail. This time we're failing because we're hitting the breakpoint. But then we can run in LDB. There we go. So we can do next. We can step into, although I'll do, which is, I'm guessing, S. Yeah, we step into next. Printing is not interesting. Starting is not interesting. We do rack slow walk. This part is not interesting because we have also printing that tells us what happens in there. And so we know what's up. We can go to the next thing and we know that this is the string and we got G is the first letter where we disagree. So we try to see did we match all? And the answer is that no, we did not match all. So we try to enter here and we say, are we looking at a merge node? We are. Is I different than keylen? It is. So we enter algorithm 1, which is where the bug lays. Try to print stuff. We do say that we enter algorithm 1. Cool. Save the next pointer. Okay, what's happening here? We're saving the current next pointer of this node. Are we doing it correctly? Yes. Suffix length. We're computing the little suffix length of this stuff. Let's see if these two variable. Okay. Suffix length is 9. This is the suffix length of the pre-existing node. We are managing the pre-existing node, so we're splitting it. So we create a split node. We wonder if we want to create a prefix node. And the answer is that yes, we do want to create a prefix node because J is not 0. J is 1. And the prefix node basically is the one that we'll need to turn into a split node. By the way, this is what might be what we are messing up. We might be failing to make it a split node. Maybe prefix. And actually you can see that, no, we don't fail this. We do make it a split node because J is set to 1. Bytes contains garbage. Actually, it's not just garbage. I think this might be undefined. Let's see. No, it's 8001, really. Okay, in any case, it doesn't matter what's written in there because we haven't written anything to it yet. So, layout split value is null. Actually, no, wait a second. Bytes should not be garbage. Oh, because bytes. Right, this is LDB being crap. So we do create a suffix. And it will be merge. Yeah. Let's look at this print. Did the print happen? Says bytes len equals 9. Hello, Jim. So we had some prints. Let's see. Okay, we're looking at the split node. Okay, so finally we see non-garbage info. We're looking at the split node. The split node has length 1. That's correct. The prefix node also has length. Wait, is that Jacob's LLDB fork? No, it's not, because I'm using the LLVM backend. Jacob's LLDB fork is good when you're using the native backend, which I'm not using yet. I think that something has already gone wrong, now that I think about it. Let me double check. Actually, you know what? Maybe I'm confusing which case we're supposed to be in. It's Ago. Oh, yeah. No, it is correct. Here's the split. Here's the prefix node. Here's the split node. This one in the center. And this is the suffix node. So, okay, so far, this is good. Yeah, so if you have Linux and you're not using LLVM, you can use it. And as far as I heard, is pretty good. Andrew is using it for developing the compiler. But yeah, you need to have access to that. And I don't for now. Okay, so far so good. 119. Do I have to build it from source? I think so, yes. But, well, I was about to say, but it's just LLDB. That's not true. You also need LLVM. But it's just LLDB. So if you have a built version of LLVM for building the compiler in general, then you will only need to rebuild LLDB, which should be fairly quick, because the changes are only in LLDB, not in LLVM. Yeah, it's pain. If only we had like Zig native debugger. By the way, if you want to have some fun, check these exchanges here. So it starts from Casey's talk. There might be other parts of the discussion that you might find interesting, but what I wanted to point out is my reply here and then some of the exchanges that happened afterwards. Since I know that you're a connoisseur, so I'm sure you'll appreciate the discussion. Okay, so we have these 3 nodes. They all seem reasonable. Let me double check the math on the 9 one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct. I mean, the example here is splitting these in 2, but they're doing it just for the purpose of showing you. Should I watch the rest? In my opinion, no. Or rather, you decide, but it's not necessary to understand the thread. Not necessary at all. Trim the compressed node. Also, I just noticed that in these cases, we're always making stuff from a new and then throwing away, like recycling the old node instead of trying to reuse it. That's a choice. In any case, we move to the prefix byte slice 0j, and we print also what happens. Let's see, where's my print? We're still stepping through it. There we go, prefix byte len 1. Yeah. So parent link is going to be the prefix. That is correct. The root is going to be the prefix now. And then the new parent link is going to be prefix pointer slice 0. Okay. That is correct. Maybe suffix. We do have a suffix, so we print it. Okay. Set split node first child as the postfix node. Yes. This is correct. Continue insertion. This will cause the split node to get a new child. The non-common character and the currently inserted key. Yes. Okay, we're getting closer to where things go out of whack. So, is iLord and key.len? It is, because we haven't added we're stuck at G, and so G and O need to be written down. So is that child pointer to node undefined? And we say if the current node is empty, and we still have, why are we doing this check? Wait a second. Let me go look at the source code. Why are we doing this? We're doing this because I could be length -1. And here we are saying that we want to enter here. Only if there is more than 1 byte. We want to enter here only if there is more than 1 byte. Because, right. Here, the idea is, do we want to make a merge node? This is the question. So let's see what the answer should be in our case. The answer is that actually, no, we don't want to make a merge node, do we? Because, look, we don't want to do that because A is here, G is in the split node, and now we just need to make O. So we do not try to make we absolutely do not try to make a merge node, but I suspect that we're going to enter in here, I fear. Key length is 3. Wait, was I? Oh, you know what? Are we incrementing I at all anywhere in here? This is what it's missing. Maybe. Let's see. J, blah, blah, blah. Prefix. We never increment I. Maybe it is by design, but if so, then I here is gonna be 1. This is 3. 3 minus 1 greater than 1. Yes. Oh. But this should be false. Haha. This should be false indeed, because the current node that we're at has bytes. So we should enter here. Hmm. But what is our current node? So give me a sec, because I am not sure what is our current node right now. In algorithm 1, the current node ends up being split, which is the center one. And that is correct. So this, we're gonna enter here. It's not gonna be empty. We're gonna enter here. And so we're gonna add a split byte to it. No, this is not correct. Wait a second. This does not seem correct, because we need to create a new node for this stuff. Why are we not creating a new node for this stuff? Because we're here. So we prepared all of these. We're here. We are in the center node. G has not been added yet. So, but there is N. So we're going to add G. No, wait, what am I saying? We have added G. We have, right? Here in our split node, we have added G, have we not? I think we might have not added G. So let's see. Here we create split. And then we concern ourselves immediately with maybe prefix and then maybe suffix. And so we set this byte to split. And then if there's a prefix, we set prefix where it needs to be. If there's a suffix, we deal with the suffix. And we point split 0 to suffix. Otherwise, whatever was the next node, we need H, and then we set H to split. We haven't added the second byte. So it means that here we should be doing this. And in fact, here we are adding the second byte. And that makes sense. So with this, we add G to that node. And we say H is add split byte and I plus 1. But there's something wrong in here. Why? What is wrong? The problem is that, yes, we move I forward, but also the node that we're at needs to change. We can't stay on the same node. We need to be on the new node. I think that the bug is how I implemented that split byte. I made it return a new pointer to the node, but maybe it needs to return new child. But then why the heck do we have this child pointer? God damn it. Let me see again. Oh, no. We do it correctly. Okay, we set age to this. And then we say the parent link should point to the new age. And the parent link right now should have been set to... the parent link is prefix node. Parent link should be prefix node. Yeah. Yeah, indeed. Indeed. So it should be this. This should be the last value of parent link. A new parent link is a slice in this node. Yeah. Yep. Okay, this all makes sense to me. I'm not sure yet how we're crashing here, but at least the rough logic makes sense to me. So we move forward, and this is going to be now we're centered on a new child that does have length 0, but this fails. So we do this again. So we basically enter here twice. Oh, you know what? Maybe it's not the first time that we do this that causes it to poop itself. Maybe it's the second time that we do this that causes the problem. Maybe it's the second loop in here. We'll see. So prediction is that we need to go in the else branch. We call add split byte. I'm not going to enter. We try to write. We succeed. First time we succeed. We set parent link to new parent link. This is a good pointer. I like it. This is a good pointer. +1. Increase nodes. Set age to child. Yes. Loop again. Does child need to survive loops? No. I don't think so. Again, we go downstairs. New parent link is set to undefined. We do add split byte. But now parent link is pure garbage. What happened? What happened there? Holy shit. No, that is not good. We put poop in there. Why? Why are we putting poop in there? And you can even see it here, like print H. This guy is supposed to be a pointer instead of this guy, like right after this pointer. What happened? What the heck happened? So misbehavior happens in a split byte. That is for sure. And it's not bad because we don't have that many lines in here to worry about. And I'm guessing that it's probably resize that is weird or something. I don't know. Oh, there you go. Here's why. So we cannot use n. We just cannot use n below this line. Below this line, n should not be usable anymore because we have reallocated it. And if we did reallocate it, then n now is garbage. And guess who's using n in here? Your boy. So this needs to be new. And I bet you that I found the problem. Also, should take out the breakpoint from the test. There we go. Now we succeed. Cool. We found where the poop was. Yeah. We did find where the poop was. Okay, so we also passed this test. 2 more cases, and then we're good. And then we are, well, you know, not fuzzing good, but we are basic tests good. Okay, so what are we adding now? Ciao. We're adding ciao. Success. Okay, so this also worked. Last one. Annie. Woohoo! Let's go. Failure. What happens? What happened is that we added Annie, and then we got an unexpected result afterwards. But we tried to add it once. But then where is us trying to add it? Oh wait, oh shit! So this fails. Okay, so we're passing key information wrong around. Basically, we are giving the prefix a key status when it doesn't deserve it. This is the bug. So it's not like we're not doing like you know, a horrible pointer math wrong. We are just have a good old more tame business logic mistake. So this has to do with algorithm 1, I believe. Actually, is it algo 1 or algo 2? I think it's algo 1. Oh no, you know what's happening? Wait. What's happening is that this, okay, what's happening is that this matches everything. And then we're saying, okay, if I is key.length, which it is because we matched everything, and the layout is split, it is not, or j equals 0, And j does equal 0 because in here, when we match everything, j goes back to 0. Where is it? Here, j is go back to 0. So here we do early break from the while loop if we have a mismatch. Or actually, no. In any case, it's a merge node. So here we break outer only in case of a mismatch for sure. So we don't. So we keep doing this until we exhaust all of until I and j have the same length basically, and then we say if layout merge j equals 0. Wait, there's something sus. And then we do this, and then we do this, and then j does equals 0 no matter what. Huh? Huh? Let's see. If the layout is merge, we obviously need to grab index 0 here. Yes. And then we always set j to 0. Okay. And then we write back j, which is going to be 0 in our case. So we're up here, and we do have j equals 0. So we do enter this condition. And here we're doing found existing is h.isKey. But that's not exactly true. Is it? I think the problem is that j should not be 0 as we return from here, because this is not what deals with a partial match. This is not what deals with a partial match. Something else should deal with a partial match, I think. I'm actually fairly certain. Because we need to split that node into things. I think it's algorithm 2, right? Yes, it is last example, so this is algorithm 2. Why are we not going into algorithm 2? Well, the answer is because our conditions are wrong. So let's see. Layout is merge, yes, and I is different than key.len. Yep. So yeah, we do go to algorithm 2. Okay. So our condition here, either our condition here is wrong or the j value that we return is wrong. We should not be returning j 0. We should be returning j set to whatever I is. And I bet you that we don't. Yeah, look. Match any, and then we return I equals 4 and j equals 0. Let's take a look at the original implementation of rack slow walk. J equals 0 is compressed, blah, blah, blah. So my code is slightly different than this one. If j is different than h size break from the while loop. Oh, there we go. I think that this is what I don't follow. If j is different than h size break. No, I do. Wait. In any case, they have the same number, don't they? Yeah, in this case, they have the same number. Sorry, they have the same value. So we wouldn't want to enter in this case anyway. So we would go here. We ignore stack push because we're not doing this. Racks node first child pointer. Rax node first child pointer. If h is compressed, j equals 0, compress node only child is at index 0. And then we, yes. And then we do parent link children dot plus j. If the new node is compressed, and we do not iterate again, since I equals L, since I equals 1, set the split position to 0 to signal that this node represents the search key. But what is our case right now? Also, this is not checking whether j is different than I. This is checking whether j is different than h size. Although at this point j should be h size. So we should not be breaking from the while loop. Also, what is happening down here? Split pause. Wait, the heck is split pause? Oh, there we go. Okay. I think the problem right now is that I'm not even sure which case we're supposed to, like which path we're supposed to take in this code. Because we are in the merge case. We want all of them to match, so we don't break from this for loop for sure. Then we go down here. We don't want to break because, okay, this double break is only in case that there is a mismatch, basically. Yeah, now I remember. The second break is entirely designed to break to the out, to make this break to the outer loop, basically. That's all there is to it. So we do match everything. So we do want to go in here. So this is guaranteed. We do want to go in here. And apparently we do want to set j to 0 before we write it back. If the new node is compressed and we do not iterate again, set the split position to 0 to signal this node represents the search key, which is going to be the case. So we set j to 0. We try to loop again, but I is not lower than len. I now equals len. Right? I does equal len. And we return with I equals 4 and j equals 0. Okay, so this seems to be correct. So it's where we interpret these return values that we are doing it wrong, I guess, then. It's up here. Where we're doing... If I equals len, and, which is true in our case, and the node is not compressed, so the node is split, or j equals 0. And the answer is that in our case, the node is not split. The node is, oh, but it's OR. So I equals keylen and J does equal 0. But we should not be entering in here most definitely, I would say. We should not. Set data, get data. Ooh, also H, wait, now that I think about it, now H should have changed. You know what? I take this back. We have overridden H. H, if I remember correctly, according to low walk, H should have changed because we override it. Where? Here. We move to the child node. We move to the child node. So now we have a new H. And H is going to be split. But this is weird. Because that should not be the case. No, H should not have changed. Let me see if this is true. Well, no, H does have changed, doesn't it? No, wait. So this is it. Okay, holy shit. Now I get it. We should be breaking here. Okay, nothing was having sense. Now it does have sense. Yeah. We should totally be breaking here because J is different than H size. J is different than H size, and we should be breaking. Are we breaking in my low wall? Oh, yeah, we're missing a condition. We are missing a condition. There we go. We are missing this. Yeah, no, this was not entirely breaking to the outer. It also added an extra condition. Yeah. Okay, now it all makes sense. So we don't do this. That makes sense. We do this. Oh, there we go. What happens now? Oh, now we pass. Okay. That was it. That was the bug. Okay. So what do? We pass all tests, finally. We need to implement removal. And then we need to finish insertion, the unhappy paths. You think this critique is unfair? Oh yeah, there are. But there's also a lot that do this. Or let me put it this way. Casey is definitely one of the promoters of that type of behavior. Sure, it's not only that. But like, well, how many people are complaining about, for example, the web being bad versus somebody doing it about something about it? You have Martin, who's making Orca. That's it, as far as I know. You're doing something about it? Wait, in the same way that about the same things that they complain about? Do you count yourself as a um as part of the handmade network? That's fine. Sorry, I don't mean to. I don't know. I'm just joking. So I don't mean to sound more serious than that. um. In any case, that's fair. The criticism is a little bit harsh, but I wanted to point out that it's not a hypothetical. It's a real thing. Your community can go down that path. I would say that probably if I had decided to word it fully, I would have said that because of the 80 proto stuff. Okay, that makes sense. Sure. I thought you were referring to. I forgot about that briefly, and I thought you were talking about like the distributed debugger thing, which actually would help with certain web stuff, but not the same stuff that they were talking about. And yeah, 80 proto makes way more sense in that sense. Yeah. What was I saying? Yeah, no. That if I had decided to put more words into this sentence, like into that section, and also pull in some more context that I did not want to pull in, I would have said that this is a criticism that probably applied to the handmade network before the more recent changes, as in Ben Business being in charge. I think that under his leadership, the network has made a lot of has improved a lot in that sense. Like I know that he has always been aware of this problem and has addressed it. And you can say that the gems are also a way of pushing people towards action. That said, Casey himself is definitely somebody that pushes people toward water cooler complaining. Actually, I think that what he does is even worse than water cooler complaining. Like his whole ref term story, way worse than water cooler complaining, in my opinion. And I don't know what's the state now in the handmade network in regards to that. But I didn't want to pull, all these things about. Like I didn't want to say, yeah, I think this applied to the handmade network before the leadership of BAM business, etc. It's too much stuff. There's a new text rendering engine in the Microsoft terminal. Is this the good result? Is this the good ending? I don't know. I wouldn't call that the good ending. Um, so let's take a look at how Rax remove works, which is what happens whenever we hit in here. I think the handling label is near the end. Yeah, there we go. Here we're ooming. So h size equals 0. Is null equals 1. Is key equals 1. And then we call Rax remove. And Rax remove is put inside an assert. Oof. Okay, let's take a look at Rax remove. So there's stuff. There's stuff. Okay. Let's get to work. Remove the specified item. Returns 1 if the item was found and deleted. 0 otherwise. I think this is public API. Takes in a Rax. Takes in a key. And takes an out pointer to give it to you. To give you, actually, it's a void star. So it's like it gives you a value. Right, because technically you're supposed to receive value. So I'm guessing that somewhere here, whereas we return, do we like set it to null or something? Old, do we use old in here? I want to see user of old to make sure that it is what I think it is. So let me scroll to where do we, here we return 1. Wait, where's old? Fix parent link. I should probably just search instead of trying to scroll and hope to find it. Immediately. Yeah, probably. Sorry, I was reading stuff on the other monitor and I got distracted. And I got distracted. If old Rax get data h. Right, which makes sense. We do a low walk to find the node. We return the value if we find it. And then we do the algorithm to undo our changes. Apparently we also need a Rax stack, and we cannot not have it. So we're gonna need to have a Rax stack to implement this, which makes sense because the way it works is that you walk down, you write in your Rax stack the nodes, the list of nodes basically that you navigated through. And then this stuff makes use of it. If the node had just one child, after the removal of the key, further compression with the adjacent node is potentially possible. Don't try node compression if our node pointer's stack is not complete because of while executing rack slow walk. ts.oom. It keeps track of ooming. Interesting. And then there's the recompression algorithm. Okay. Well, we can implement this. We're going to need to take a look at what Rack's stack looks like also. I guess we can see the struct definition here. Points to static items or a heap allocated array. Size the items, max items, number of items contained, and total space. This Rax stack smells a lot like an array list. Up to Rax stack items, we avoid to allocate on the heap and use the static array of pointers instead. And then true if pushing into the stack failed for at some point. Which is interesting because I'm curious how this is going to be handled then in the other code. Okay, let's go implement it. But it's public API, right? So it should go, I guess, under get output. And we can call it pop, maybe. I think in Zig land, this is usually called pop. Remove? Never mind, it is called remove. Oh, but it does not return the value. Fetch remove. And it gives a key value. In our case, it would just be a value. Okay. Function fetch remove returns what? Returns a t. What are these things implemented in here? Fetch remove calls fetch remove context. Which calls fetch remove adapted, which does the actual fetch removing. And what about remove? calls remove context, calls remove adapted, which does way fewer stuff. Interesting. Let's do fetch remove for now. I need an allocator. We're gonna need a key. So the way this was done in the C case is that instead of having a dedicated fetch remove API, we had an out parameter that you could set or not set. It's actually not that bad. It doesn't seem a bad choice. It's not very idiomatic for us, though. Let's keep it a fetch remove for now. And we need to decide, we have to decide what to do with Rax stack. We need to decide what to do with Rax stack. We could make a stack fallback allocator. Yeah, a stack fallback allocator using this stuff. Let's see how it would do. Let's see how it would be, sorry. Actually, does that even need to be that? I don't think it even needs to be that. I think it's an array list that we can initialize off of a array on the stack. Let's see if array list supports this naturally. It should, though. Like, I would hope that array list does support this directly. So like this. $32. You will need to store whether to free it. Yeah, but it might. Are you sure it does not? It does have a bunch of weird initialization functions. Although you're right, usually it doesn't have like a bit dedicated to that. So yeah. Well, let's see what we have, I guess, in the standard library. Oh, you can. Okay, you can. Okay. You can init it with an array, but then you cannot use any function that takes an allocator. Well, that sucks. So we need to compose it with stack fallback. Is that it? I mean, it could be worse. At the end of the day, it's not that bad, I think. So what do we put in there? I think it's pointers, right? Pointer to nodes. This is heap dot. Oh, you don't even need to make a buffer. Okay, it holds it. Oh, that's awesome. 32. Of that size. So 32 times size of pointer to node. Not init GPA, I'm assuming. I didn't see any init though suggestion. So is there no init? Unlike most STD allocators, stack overflow allocator modifies its internal state before returning an implementation of the allocator interface, and therefore also doesn't use the normal allocator method. So you have to use .get. Am I supposed to set these values myself then? I am I? Buffer is this. Fallback allocator is an allocator. Fixed buffer allocator is a fixed buffer allocator. The init is external. Yeah, so this gets set by get. So, but this does not have a default value. The buffer is, I guess, oh, there's a function for it. God damn it, thank you. Yeah, this part was like, it's up here. Right, sorry. I was scrolled back and I didn't see it. And okay, that makes sense. Okay. And hey, where's my thing? Oh, it's stuck pulled back. Dude, please. So 32 times size of node. Wait, is this giving me any alignment info? Because if this guy doesn't give me alignment, then it means that we might need to pad the first item. And so I'm not gonna be able to fit 32 of these two guys. Can you set alignment? You can align the variable, right, because it's embedded inside. Well, I can, but do I get guarantees that this guy is gonna be the first member? You don't get the guarantee, do you? So even if I align the variable, these guys might make my alignment go out of whack. They won't, I think, because these are structs, right? Concretely speaking, these guys won't in this case. Yeah, this guy won't. This guy won't. So yeah, it should be fine. But I think it would be better if it did accept this. But I should be getting anyway, right? Structs do have an alignment, right? Or rather, usually their alignment depends on what they have inside. But let's say that I have a struct that only contains a single byte. Is that struct going to be aligned to one byte, or is it going to be aligned to more than one byte, just by virtue of being a struct? Maybe in the future. Okay. And then we need the fallback allocator, which is going to be GPA. Okay. To have the stuff fallback allocator. Oh, wait, the problem is that this is more complicated than this. Wait, because this needs to be a type that we pass around and then we know how to manipulate. And it keeps track also of ooming. It needs to be ooming aware. So yeah, we need to make a type for this. I guess I'm gonna put it under node. Where do we put alignment? In here, right? What a delightful signature. Before the equal sign. Okay, one sec then. Okay, stack. We're saying this goes before the equal sign. So like this. What? What a delightful signature. If you ask me, this is a delightful signature. Truly delightful. And then we have which is a boolean. And I don't think we need anything else. Wait, no, we have the software like allocator. Where's the array list? Items. It's not items because the array list contains items. I'm gonna call it node. Or just list, maybe? Nodes. Node list. There we go. Node list. The problem now is that we were saying that the stuff fallback allocator resets its state whenever you call the interface, whenever you grab the interface. So it means that we need to have we cannot lose the interface. Hopefully this is not a problem. I haven't seen yet all the usage patterns, but I don't think we need to store it, so we can probably make it do without. Let's see. Oops. So init gives you a stack. Give me GPA. You give me GPA, and I give you this stuff. Return SFA equals SFA. Oh, wait. This might be the one case where we want array list not unmanaged. I don't know. We'll see what happens. This may very well be the one case where you want the array list to keep track of its allocator. You know what? The problem is this init is not really going to work. I think we're going to need a pointer stable init. I know that I have a struct right here. Yes, but the difference is that if it's an array list, then you can use its methods that already have reference its own storage of GPA. If I put it here, then you still need to wire in the correct allocator, or I need to provide you with convenience functions at this level, which you know what, and anyway might not be a bad idea. Yeah. So I guess we don't need self at this point. We can do this, I think. No, I'm wrong. We need self still. Okay. The original code supported further attempts after and just don't use the stack in that case. Did it? Okay. I'm gonna fix it then once I get there. Thank you. Void. Oh man. Now the anything is gonna be fun. So with the init the Radix, with the init, actually we don't need any GPA, right? Because it's bundled inside stack fallback. So stack dot node list dot the init stack dot sf allocator. What does it need to be? I think this can be const, and this of course can be const. It's written this way because remove isn't supposed to be a fallable operation, so we fell back to leaving the data structure as a bottomal yet valid state. Oh, but wait a second. Then when you're talking about this, are you wait, with this you're talking about the Radix tree itself, right? Not the stack, a Rax stack. Or are you talking about the a Rax stack specifically? I guess I'm gonna see this in a moment in any case, but it does have the init, right? Get alloc resize remap free. No. Wait. How are they init this? Yeah, that part makes sense to me. What I'm asserting, so the assert that I added was that you shouldn't be, what I would expect is that you don't attempt to append again once you hit once. That's what I was trying to check for. I don't know if the code will attempt to do that or not. So maybe there are reasons to make this in a sense like idempotent. Once happens, you keep appending. Okay. Okay, so that's how the rest of the code is structured. Understood. Understood. Okay. Okay, you know what? I'm gonna read the original implementation after I'm done with this. How do I init this freaking fallback allocator? This is driving me nuts. It doesn't have the init. It has get. It has unlock. It has resize. It has remap. It has free, which is all well and good. How do you de-init this thing? It's just bytes, man. Okay, so I guess I de-init the... Yeah, I de-init what? Oh, I guess I do nothing because now that I think about it, okay, I think it's starting to make sense. So the way it works is that if node list was using the stack, there's nothing to the init. If node list was using the heap, then the initting the node list frees everything that's on the heap, and so there's nothing else to do. Okay, so this should be it. Yeah, and the free is called by node list the init. So this should be our the init in its entirety then. Okay, let's see what the original implementation was doing with this stuff. Oh, of course, here's the type, and then what operations you can do on that type. Good luck. Rax stack free. Let's see. So these are all the Rax stack operations, huh? Let's see. Rax stack functions. The Rax stack is a simple stack of pointers that is capable of switching from using a stack allocated array to a dynamic heap once a given number of items are reached. It is used in order to retain the list of parent nodes while walking a Radix tree in order to implement certain operations that need to navigate the tree upward. Okay. So we initialize it. We have push. Yeah, lots of math there, lots of logic that we don't have to worry about. Where's the ooming part? Oom is set to 1. And returns, I guess, failure. Oom is set to 1, returns failure. And it just does not care about oom ever. Okay. Rax stack pop. Pop an item from the stack. The function returns null if there are no items to pop. Okay. Be sure the original Rax oom handling is broken. Their oom test never ooms. And when I forced it to, tests broke. Once we have fuzzing, and once we have everything in place, man, testing all the failures path would be cool. So stack pop, I guess. Stack peak and stack free, which is our the init. Stack padding. Okay, let's add then pop and peak. The heck is peak? I guess it's get head basically. Is there a last? It would be nice to have a last. Get last. Ha! Let's go. Oh, but assert that the list is not empty. God damn it. Get last or null. Okay. Okay, so we have this. Then we can implement Rax remove. I don't remember where I opened the tab with Rax remove. I guess this is gonna be the tab with Rax remove. Okay, let's start copying some code over and re-implement it. How is putting a set effect in assert in C not a bug? A good question indeed. Crypto Code was pointing this out also the other day. Well, I guess the answer could be that maybe assert is defined as something other than normal assert. But the answer is that no, that's not the case. Aser comes straight from aser.h. So the answer is, I don't know, man. I genuinely have no idea. Well, you know what? I'm not sure how it's implemented in aser.h. I guess I would have to take a look. Let's take a look at this muscle repo. So now, where is assert? I guess it's include assert h straight up void 0. Oh, but only if you do end debug, right? So the point is that they're basically expecting you to not do end debug. Well, I guess the question is, this is so crap. I don't know, man. Freaking C. Well, 10G switch in the mail. Nice. My internet provider just told me that they are selling 2.5 gig connections. It's not even that expensive. It's like 40 euros a month, I think. Actually, less than that, like 37, I think, or 39. And it's 2.5 gigs down and 200 megabytes up, which is pretty nice. Pretty nice. The thing is, and actually I could do it because I do have a 2.5 gig a router that also can switch a couple of 2.5 gig connections, so I could hook the fiber bridge to it on one of the 2.5 gig ports, and then the other one to my main computer, and then everybody else in the house will have to make do with just 1 gig. And yeah, $10 a month more to go from 1 to 2.5, but it's not offered in your city. Oof. Yeah, it sucks. Although, to be fair, I mean, 1 gig is already plenty good. I haven't upgraded. I don't think I really need it. But it's cool. Okay, what were we saying? Right, we were looking at asserts. I lost Raxel move again. By the way, I was trying to go back and going back wasn't working, so. Okay, I copied the code already. Now I remember. 8 gig symmetric. Nice. And nothing in my house is more than 1 gig. Jim, please don't comment about France to Blurry Cat. We've already had a bunch of French pride discussions in this on this channel already in the last few days. Why is stack called TS? Why is it TS? Isn't it supposed to be ST, if anything? The stack. The stack, right? Oh my god, you both. You both went for it. I don't know. Okay, ST. Are we relying on zero initialization here? We are, right? I think we are. No, we're not. We're anything explicitly. Okay. So we don't care about the parent link. Split IDX, yes. I think I'm just gonna call it stack. I don't like this 2-letter name. Okay, also in Rax low walk, now this is not a pointer to an enum pig anymore. Now it's an optional pointer to a stack. And where it's set, we need to do what needs to be done here. So let's take a look at low walk and implement this path. Oh, we can go from here. Let's go low walk. If it's present, we just push H in it. Okay. Wait a second. This thing is eating ooms. Right. Okay. So this is what Jacob Lee was saying earlier. Failure in these operations don't block anything else. They just oom and then they don't care. Okay. So this is s dot push append h, and append is not something that can roll out anymore. And we catch oom through, and then we return nothing. Yeah, you oom into the void. That's just how C works. No, well, I mean, it makes sense. To be fair, I think it does make sense for this type of stuff to work this way, because even you could be more explicit. So you could make this fallible, and then somehow I mean, what you would do is basically everywhere you just catch do nothing. That's the idea. Which, to be honest, might not be a bad design choice. It's definitely more explicit to do catch do nothing, isn't it? You know what? I think I'm gonna do it. I'm gonna keep this as something that errors, and then I'm gonna do everywhere catch do nothing explicitly. So we have a track of the catching happening. I don't think we do anything else with Rax stack. So cool. Low walk. Okay, back to fetch remove. By the way, in about 10 minutes, I'm gonna go because I have a meeting. Let me double check my timings. Yeah. The old code returned a status anyway. Oh, so it did. Right. You're right. It does return something, but I guess nobody cares. At least for now. And maybe somebody else will, something else elsewhere will care. Here we don't. We go back now to, please. I love GitHub. Okay, you know what? I'm done. We're cloning this guy. I'm just done. I can't anymore. Do I have it? No, I don't. Thank you, X2. To answer my question above. Oh no, I lost your question. Wait, what was your question? Oh, are there examples or it could be the build product that use auto tools? Yeah. Yes, you want that, but then you will have to come up with you know, all the variables. Okay, rax.c. Let's fucking go. Rax remove. Go to definition. Man, I can even do go to definition. Why haven't I been doing this earlier? I'm dumb. I really don't like auto tools. I've had interesting discussions about auto tools recently because Johnny Martler came up with an interesting approach to this that Andrew then cautioned against. But I think it's still, the whole story is interesting. So meeting at 7 p.m. on a Saturday, yes, that's my life. So the thing is, basically, I think they both have a point, which I find nice. Johnny was looking for a way of replicating AutoTools behavior completely with the Zig build system. So AutoTools works off of basically feature detection in the system. For example, you have a project that uses AutoTools that can build with SSL or without SSL. Depending, if you have it, it adds support for it. Otherwise, it doesn't. So how does this work? Well, in the Zig build system, what you would do normally is that you had a flag for that. You say, do you want SSL support? And then you turn it on when you want it, and you don't turn it on when you don't want it. What AutoTool does instead is that it tries to make a tiny program that tries to import AutoTools. It tries to import the SSL stuff and compile it. And if that works, then great. If it doesn't work, then the feature gets toggled off. And maybe it's not always making a tiny program. Maybe in some cases it definitely is. In some other cases it's not. I'm not sure if the case that I just mentioned is actually one that is resolved by making a tiny program. I think this is also something that you could test just by asking package config, I guess, maybe. In any case, it can do that. Yeah, this obviously does not work with cross-compilation. Not only that, it's also not useful at all when it comes to fully with builds that are fully, let's say, hermetic. Builds where you're only using stuff. You got AdWalled. Oh no. So when you're building a project in Zig that only uses the Zig build system, it doesn't have any system dependency, then the AutoTools approach is completely useless. So Jim, wait, are you being AdWalled right now, or were you being AdWalled earlier? I'm guessing he's being AdWalled right now. So we're not going to make progress until he comes back. Okay, you're back. So what I was saying is that, so AutoTools does feature detection on the system. It runs a bunch of it tries to compile tiny programs to detect features of your system. And the idea is that a project can dynamically toggle these features on and off, and the project is fine. Like, the project doesn't necessarily need SSL support, but if you have it, if you have OpenSSL in your system, then it will add support for it. So this is fine. This is not useful for cross-compilation because, as CryptoCode is pointing out, well, if you want to do cross-compilation, good fucking luck, because you need to do feature detection on the target machine, which you currently do not have. Point number two, if you're making a build that is entirely hermetic, like it's entirely managed by the build system and Zig dependencies, like Zig package dependencies, so you do not do any system integration at all, it's also useless in that case, because you will know perfectly which sets of features you support or not. To be fair, when you're packaging a C project that uses AutoTools, it will take you maybe some work to get this to dial in precisely this stuff per platform. Because, for example, maybe you test it only on Linux and you enable SSL, but then it turns out that on Windows, SSL is not supported at all. Not really a realistic example, but some other feature might not be supported at all on Windows. So unless you test on Windows, you should toggle that off. And vice versa, there might be features that are like Windows only that you don't even care about on Linux, but that would be nice to turn on Windows, for example. But when you are instead doing full system integration, then in that case, if your goal is to replicate entirely all the feature set that AutoTools gives to the project, so the idea is, my goal is to take a C project and be able to build it with Zig, without AutoTools, without any other dependency other than Zig, or rather, other than Zig, and I guess the system dependencies that you want to hook into, then this approach will allow you to replicate one-to-one the same feature set. And when I say this approach, I mean something that Johnny built. Johnny built basically a bunch of code to do what I just described. So like do feature detection, auto tools style. He basically re-implemented some of the auto tool logic in Zig. On the other hand, though, my understanding is of what Andrew wants to do in general is to just consider auto tool a bad approach and not attempt to replicate precisely what it's capable of, and instead force everybody to go away from system feature detection and instead more explicitly opt in and out of each feature. And in some ways, it's also kind of like the approach of I want to build a C project and I will recursively scan a directory, find, or like a path, find all C files in there, and automatically pick them up and compile each and every one of them, versus hard coding the list of C files that you want to compile. And while hard coding the list of C files that you want to compile is obviously annoying because you have to, do the typing work to get that in, and then every time you want to add a new C file, you need to also add it to the build system, and maybe you wouldn't want to do that. But at the same time, it does make the build way more predictable than it would be otherwise, which is interesting because this also ties back to a thread in Zig where somebody was saying this, that they made a template for the Zig build system to compile C++ projects that does the stuff that I described. Like, for example, it configures build.zig to recursively search the source/cpp directory for CPP files and compiles them using the following wordings and syntax, blah, blah, blah. So I think it's interesting to see how you feel about these approaches. If I have to be honest, while on one hand, I understand the nice aspect of not having to type in every C++ file that you make, on the other hand, this is kind of disgusting a little bit, because it's obfuscating, right? It's obfuscating what ends up in the build. And again, I don't want to say that this is inherently bad. I just don't know. And I understand why people would want to do this. And the build system allows you to do it. So it's not like they're doing anything that the build system would otherwise entirely prevent them from doing. But. Last thing. Actually, I take back one thing that I said, because this might very well be something that eventually the build system will not allow you to do as easily. Because if we're talking about sandboxed build scripts, a sandboxed build script will not be able to recursively scan your directories. So that means that you will have to have written in the build script exactly which files you want. Unless for some reason the API, unless for some reason the runner, the ecosystem in which the build script will run will allow you to do that. I don't know. I don't mind listing all the files. Yeah, same for me. I'm not a CMake-AutoConf fan, so I try to avoid projects that use them, but in this case I have to. Does that mean that my hacks to embed directories in my executable from build.zig won't work anymore? Yes, because you're doing the same thing, right? Necessarily, if you want to embed a directory. I do think that it probably would make sense for the build system to allow you to do that still after after moving to potentially WebAssembly to like a sandboxed runtime. But I don't know. Yeah, to be honest, listing these files is actually like so fucking easy. Like you just do basically ls, or like you do 3, and then you can figure it out, and then it becomes just a copy paste and then a couple of macros in your editor, and like you're done. Still, I don't know. Add embed there. We'll see. We'll see. In any case, we made some progress. And this is cool. And I think I'm going to stop here. So thank you all for hanging out. And let me think. I think that tomorrow we're going to also make some more progress. We need to implement remove. So we made some improvements to the API for Flex. This is really cool. More improvements down the line. By the way, I'm that set on destroying C flexible array members and make a strictly superior type safe approach to them, which obviously will not solve every use case, because sometimes, I don't know, you will have wild enough needs that my abstraction will not work for your use case, but it does work, I think, in a good range of them. And so far, it has worked flawlessly for Rux, because as far as I'm aware, we have not lost anything. Like, it's not like even there is a single algorithm that has been pacified because of the type safe abstraction. So far, so good. Let me see if anybody else is doing Zig. There's Lucas Develops. I'll send you all to Lucas Develops. Enjoy, and see you tomorrow.